Alright, now question 38 is a bit tougher than the other ones. For question 38, look at it. Cosine squared is not really a composite function, but this one is. So, as usual, let's start with our outer function f. In this case, the outer function has to be the square root. So that's it. And the inner function g of t is going to be 1 plus tangent of t. So obviously, this, as usual, is going to give us our substitution variable u. So in this case, u is equal to 1 plus tangent t. Okay, so let's look at our question now. This term here is going to be taken care of by substitution. What do we have left? We have dt divided by cosine squared of t. So we have to get rid of this. Okay, let's start our usual method. Take the derivative with respect to t. 1 goes away, and we're left with secant squared t. Oh yes, secant squared is good news, because secant squared is just 1 over cosine squared. And if I bring this up here by cross multiplication, I find du is equal to dt divided by cosine squared t. Oh, this is working out really nicely. You know, it looked really complicated about 2 minutes ago, but now, no problem at all. So, I have my replacement, which means I can start my substitution. Let's start my substitution with this big term goes away, and we're left with 1 over the square root of u. What happens to the dt divided by cosine squared of t? That's just replaced by du. Okay, but this is just an integration of u to the power negative a half. And we know how to integrate this. This just becomes increase the power by 1, so u to the power a half, divide by the new power, so divide by a half is multiplication by 2, plus constant of integration, because it's indefinite integrals. Now, last step of the problem is to replace the u's with t's, and so we have 2 times 1 plus tangent of t to the power a half plus constant c. You can also write this more conveniently as 2 times the square root 1 plus tangent of t plus c.